Okay guys, so in this video I'm going to show you the boring server architecture. So let's get into it. Now, this is, let's be honest here, a little bit of a dramatic name, but it's something that, honestly, I don't know why so many people are against this sort of architecture, because it is a proven, tried and true architecture that is very, very popular in large scale companies, and it works very, very well. There are absolutely things that could be nicer with it, but so far I haven't really seen like a server-side architecture that works as well as this at scale. So that's why I wanted to show you how it works, because basically I'm not saying that this is the exact implementation, but there are different flavors of this. But this server-side architecture that I will show you in this video is going to be the most common way that you will see large-scale companies write their software. So let's just dive right in. So what we're going to talk about is basically what it is, why it is so boring, and why people are trying to reinvent it, and why it's such a popular architecture, and when you should use it. Now, to kind of just as a disclaimer, I'm not saying that the exact thing that you're going to see now is the exact thing that you're going to see in every other project, but the architecture, the general idea, and the layout of the project is going to be very similar in many cases. And I can tell you right now that I've seen this flavor of architecture in pretty much every single project that I've been working on when we're talking about a larger company, like professional level software development. But what's funny is that it's not that common in Node land. Architecture is the one that I find to be most common in C Sharp or .NET, if you will, and in Java. But enough talking. So let's talk about let's just walk through the file system. So first and foremost, we have our initialization file. Basically, we're just requiring our application, and here we have our Mongoose connection because we're using MongoDB for our database connection, and then we just bootstrap everything up. And you may ask, because in order to kind of make this into something that is fairly modern, Docker is something that I like to use, and it's something that is very common especially Node.js land. It's very, very common that you use Docker. So here's our little Docker file where we just create a container with Node, and then we copy all of our stuff from here into the app folder. We set the work directory, so inside of the container we're finding ourselves in /app. And then we install our production dependencies, and when you start the container, it's just going to run the server, right? This is a fairly an easy implementation. You can of course add on to this, and then we have our Docker Compose file, which you would probably in professional level, like production levels, software development, you would probably use something like Kubernetes for this stuff, but Docker Compose is good enough for local development. So we declare our application, which is going to be the thing that we're building here, right, basically, and it depends on our database instance, which is just an image with MongoDB that exposes the normal ports. And then we inject this little guy here. Basically what we're saying here is, we saw earlier, the server is going to check for this environmental variable. If it doesn't find it, it simply defaults to this default URL. And this is just so that we can run we can run our server locally, and we can also run it as part of Docker Compose, because in Docker Compose you will actually see that you have your own closed network, and that's why you have this little domain alias here. Anywho, we bind our ports. Great, awesome. So this means that now we can kind of spin up our application, if you will, and then we use Git, of course, for version control. If you're using Mercurial or something else, that's fine as well. But in my experience, Git is by far the most standard or most common thing. And we have a Docker ignore file. This is just so that when we copy, as you saw earlier here, what we're saying here is dot means this directory. Copy everything in this directory, which is, we are assuming that we're running it from the root of this project. So copy everything over to app, but the Docker ignore file is going to help us to not actually copy over the stuff that we don't want to be in the container, because we don't really care about like the local node modules, for example. And the reason why we don't care about that is because when we run our install, we want to run it with a production flag. And if we look at the production flag, Basically what that means is that it's going to grab these dependencies and not these dependencies, because we don't want our testing framework and our testing stuff as part of the build or like of that application, right? So that is a nice segue into our scripts that we have set up. Now you can use many different ways of like running your server tasks. I personally like to use the npm scripts, but if you're doing if you have an environment where you have multiple people working on the project and you have several different systems, I'm on a Mac, and some people you like to use Windows, and some people like to use Linux, etc., etc. You would probably use something like Gulp or Grunt or something of that nature to kind of abstract away the specifics of the environment that you're working in. But let's do npm run make, which is this little script that I put up so that we have our database instance up and running, and so that we get our dependencies installed. And as you can see here, all I'm doing is that I'm basically doing docker run rm, so that when I kill the container, it's just going to go away. I bind my ports, and then I set it into daemon mode, so that means it's just going to run in the background. And I give it a name of db, and we're going to use the Mongo instance for all of this. And then we asynchronously, using this little operator here, or in parallel if you will, we install our dependencies. That's awesome. So now all that is installed, docker ps, and yeah, as expected, we have our database running. Awesome. So let's just do this. Let's start our application, and let's have a look here. Localhost. This is our boring application. This is, yeah, it's the most standard type of application you can imagine. It has some basic routing logic or like validation logic. You can register and you can log in, and then let's just look at this. I do a foo and a bar, and now I'm registered and now I'm inside. So here I am. I can add some content to my little list here. And we do a bash, and that's basically it. That's the entire application, because we're not really here to impress anybody with our fancy application. We're just walking through the structure of the server or of the project itself. So this is like the infrastructure part, if you will. This is the part where like how you start the application, kind of how you run tasks and stuff of that nature. And usually you'll find all these files here in the root. These are like the things that are happening around your application. So usually what I find is that you have this sort of layout here. So if we open up our index.js file, which is the entry point. Now, if you're using something like Java or C# or anything else, like doesn't matter which language, you can use anything, but every single application usually has some type of entry point. And in Node, there's no difference, right? So we are running an Express application, so instantiate, and we use Express session in order to do some basic validation logic. And then we have a bunch of controllers. Now, the name controller comes from the pattern that we like to call MVC, or Model View Controller. And the idea behind this is basically that it just stands for separation of concerns. In other words, in order for you to have a if you think about the M stands for model. So in order for anything to be possible to do, like in the rest of the system, to be useful to you, you need to have a model. And a model is just a data structure. It's something that you store in the database. The view is a representation of the model. In other words, the view is like an HTML page or JSON or anything that comes to the client, something that the system exposes towards whoever is asking for the data or for making a request to the server, right? And the controller is the glue that kind of orchestrates everything. The controller is responsible for handling the incoming request and responding appropriately both to the internal system and to the client making the request. In other words, it's the orchestrator of all the things that are happening in the system. So here we declare where our views are found, which is here. We have some basic pug files. We'll just very quickly look at those. We declare our session with our very, very secret. Don't tell anybody about this very secret. And then we declare that we can handle URL encoded post request, in other words, form submission, stuff of that nature. And then we declare our static assets, in other words, where we find our CSS files and this JavaScript that's going to be sent to the user, right? And then we just add our controllers and export the app. That's it. let's just very quickly look at, like, here's our index.html file. Like may not be all that interesting because it's just a bunch of basic files that renders into HTML, right? What's interesting though is the controllers. So here we have our index file, which is just an entry point into the controller, so I can import. I basically just require my controllers here, and then I export them as a convenience to the consumers who want to import my controllers. So let's look at the home controller first and foremost. So we declare our router, and then we grab our user model. We'll talk about the user model in just a moment. And here's something interesting. We have something called a user service. Now, traditionally, what you will do when you have the quote-unquote boring, I don't know even what to call it, but the way that I was taught it, it's called a paradigm that is called domain-driven design. And domain-driven design builds on the idea that you have these natural entities. You have a user, you have a product, you have a cart, a basket, whatever you want to call it. You have these nouns that describe different entities within your system. And the idea is that you have a model that represents this entity, and then you have a service, or you have something that allows you to kind of touch and work within that environment. The way that I was taught, it's basically just what we call a service. So we have a user service which is responsible for all the things that has to do with the user. Now the model is just a container of data. This is just where the data lives. But the service is responsible for everything from saving the user to updating the user to sending, like, you can have many services. You can have email services, you can have product services, all and so forth and so forth. So what the controller does is that the controller takes in the request and simply delegates logic to the service itself in a perfect world. So if we just have a look at this, so if I go to the root, I'm going to render the index file, which is what we saw earlier. That's just a login form, and then register just renders the register HTML, right? And then we have our login, which is just we grab the username and the password, and here is where the magic happens. Now notice that I could have, if I wanted to, I could put all the logic that is in this user service get user that takes a username and a password. I could put all this code inside of this controller. This is where the idea of domain-driven design comes in, because the controller, if your controller is responsible for doing all that logic, you will very quickly find as the system grows that you might want to be able to do many things. Like, what if you want tracking stuff and you want to notify other systems that somebody tried to post a login? What if there is an invalid login? Maybe you want some type of threshold for how many attempts somebody should make before they're allowed to be before you like alert that somebody's trying to hack your system. There's all these different things that you might want to do when the system gets big. And the problem with putting all that code in the router or like the controller method here is that this method is going to be massive. It's going to be it's going to be enormous, especially if you have a lot of stuff going on at the same time. And that's where these services come in. So the services is just a layer on top of all the logic, where you allow one service to be associated with one specific part of your domain, and all the logic that is associated with that domain the service owns. In other words, my user service owns everything that has to do with the user. My product service has ownership of the product. My emailing service, I hope this makes sense to you, right? And then we have this little in-between thing where we just check if the user is, if we find a user that is associated with this username and this password, and then we simply, we set our user ID on the session if there is something like that, and then we redirect to the to-dos, and now the user is logged in. Otherwise, we simply return a 401 and say that, hey, you have invalid credentials. That's basically it. And the same thing kind of goes, if you do a post to the register, in other words, when you register a user, we grab the username and the password, we store that in our user model. Notice that what I was saying earlier is that the user model is only responsible for storing the data. It's just the data, that's it. And then the user service is responsible for saving the user, and then we set our session ID and redirect to the to-dos. And that's basically it. Now, the criticism a lot of people give this users, like this service-oriented architecture, and like people want to go towards like more functional stuff and stuff of that nature, is that the services can very quickly become this bucket that does everything. I mean, I've seen service methods where they do like 100 different, not 100, but you can just get my drift when I say that it's very easy for you to dump a big pile of logic into one service method, and all of a sudden it becomes all but impossible to test a service. Services are notoriously tricky to test. And my personal opinion here is that I think that this is one of the reasons why functional programming became such a popular thing when, like, in more modern times. It is simply because when done right, functional programming is very testable, and service-oriented architectures like this is not as testable. But the one thing I have never seen anybody be able to do is to write a really, really large code base in a completely functional, well-maintainable way without compromising something else. The service-driven, like or quote-unquote what I call the boring architecture, it scales very well and it's very simple. If you take away anything from this little video of mine, it should be that this is by far the most common way that you will find server-side architectures being done in a monolithic application. And this is just my speculation, of course, but I argue that the reason for that is that it's very accessible and it's very easy for developers of different skill levels. You can be super senior or you can be fairly junior. This way of working makes a lot of sense to a lot of people. Let's look at the to-do controller. This is where we kind of have our restrictions. As we can see here, we have a to-do model. We're grabbing our services again. And this is where we have our little middleware here, which is like the most common middleware you will have in ExpressLand, which is like, it just checks if somebody's logged in, because these routes, you shouldn't be able to get to those unless you are logged in. And literally all it is this little function here. It takes in the request, and all it does is it checks if you have a user ID. If you do, you're allowed in. Otherwise, we're just going to redirect you to the index file, to the login page or the root page, right? So we're validating you here, we're grabbing you, getting you all the way in, and then we have this little service here called the to-do service, and its job is to list all the to-dos. That's it. And then we render the to-dos to the to-do page. That's it. And then if we post to to-dos, we check that you are logged in again, because we don't want you to post things if you're not logged in. We grab the to-do. And then we do this. We get the user by ID. Remember, the user service is responsible for users. So now I'm grabbing the sessions or the user ID that is associated with this session. We grab that user, get it into memory, and then we store the to-do with the to-do and the associated user. That's it. And then the to-do service is responsible for adding the to-do, and then we redirect to the to-dos, which goes back here, and now we list all the to-dos again. Easy peasy, right? And that's basically it. Let's look at just for the sake of completeness, look at all the other stuff as well. So here we have our models. The to-do model is super, super trivial. It's just, I mean, this is not production level, like a production level model or anything like that. It's just kind of an illustration. So we have our to-dos, we have our user model, fairly straightforward stuff, I hope. Here we have some public assets, and the only thing that we have that is public is this little CSS file. And then we have our services, which is of course the meat of the stuff. We're going to talk about services in testing in just a moment. So the way that I like to do this, because like in languages such as Java and C#, for example, you will have something called dependency injection. Now, dependency injection is absolutely something you can do. If you want to do that, that's fine. I personally like to do things this way. I will hopefully make this a little bit clearer once we talk about testing, but the way that I do, like when I create services in JavaScript land, I do it this way, where I grab my services and I put them all in one file, and I do this, and basically I just list everything and then I export it as part of my services. And the reason why I do this is because I want to have the least amount of hassle and the least amount of complexity in order to instantiate my services. And this is the easiest way that I know of how to do this. It doesn't require any tools, it doesn't require any impurities or anything like that. All it is that I'm grabbing my object, instantiating it with the dependencies, and then that's it, and then I export the instantiated service. Easy peasy. So let's look at the to-do service. Now it's just a JavaScript class that takes in the to-do model, because the to-do model in a MongoDB or a Mongoose API or the Mongoose library represents our connection to the database, right? So we put that on our service, and then we have a few binds here so that we can keep track of our this keyword if we ever need to do some nested Lambda functions. And then this is the service. It does this to-dos.find internally and returns all of the to-dos. And then we have add to-do that basically all it does is to take in an instantiated model, and then we do a save and we return the to-do. Now this is of course very trivial, but what's nice about this is that you can add as many features as you want without a lot of complexity, because you will simply add another method that represents the thing that you want to do. And it scales very, very well. It doesn't get, like, at large scale, it gets a little bit messy if you don't take care of your services, but it's very easy. It's very safe to work in this manner, and it will scale up from the smallest little company, your own little Kickstarter startup or whatever, up to the scale of Google. This will scale all the way up to that size. I can promise you that. This service, this way of working scales up to the biggest size of company. And then we have our user service that has a few methods, and as we saw earlier, we just store our database connection here, and then we have save a user. Here we get the user by just getting the username and the password, so we do user.findOne, username, password, get user by ID, easy peasy. So remember, all it is just a service is just an abstraction that is one level below the controller. So instead of putting all this logic in the controller, you create a service that is responsible for this part of your domain. Now, let's run some tests. So npm test, let's run those. So let's run our tests and see how that works out for us. And after the test run, this usually means that there are synchronous operations that weren't stopped in your test. Yeah, that's awesome. But as you can see here, like, all my tests are passing, and now we're going to move on to the thing that is next, which is testing. So here I have my directory called tests, and we have a few tests here. Now, the way that testing works is, like, you will have unit tests, and then you will have integration tests, and there's a few flavors of testing. I'm not going to dive into all the ways you can do testing. I can just show you the kind of the basic way that you will see people write testing in production level software. So if we have a look at the model first and foremost. So here we have a very basic test where all we want to do is to assert that the model's serialization is working correctly. In other words, we want to be sure that when we save our model, we have decided that it's going to have this shape, it's going to look this way when we get it from the database, and that's basically it. So what we do here is that we create our connection to the database in the test, and once all our tests are done, we simply close the connection, and then, yeah, before each, we simply remove all of our to-dos. So in other words, we just clear the state, right? So all we're going to do now is that we're going to declare some data. We're going to instantiate a user, and we're going to instantiate a to-do, and then we simply save the to-do. And then we we search for the to-do in the database, and what we're going to expect is this shape. In other words, this is the expected output from what we're getting from the database. And then we convert these two to a string, and then we just do an equality check, and that's basically it. Now, you don't have to write tests in this exact way. I like to have a few serialization tests, and I know, like, at the company I work at today, we use this sort of testing as well to just make sure that we actually have the model that we expect. This is especially true for a loosely typed language where you don't have a nice error that gets thrown if you're basically getting a model from the database that you're not expecting. This wouldn't be less of an issue if you had a typed language like Java, for example. But be careful. Ideally, you don't want to have too many tests that go to the database, because they get slow really, really quickly. And just trust me on that one. Try to keep these things to the bare bones minimum, and we'll see exactly why later. We will see in the service test in just a moment. And then we have the same sort of test for the user model, where we basically do the same thing: create the connection, close the connection after we're done, remove everything before, so that we have a clear database before each test. And then we just create a user and make sure that when we get it from the database, it has the shape that we're expecting, right? Then we have our controller tests, which are basically like these you can make kind of fancy. Like, it depends on your testing strategy. I like to keep these fairly straightforward because my controller shouldn't be doing too much. I just really want these tests to be there, so I make sure that the endpoints are there. So the way that we do this is basically we create our instantiated database, and then we close it once we're done. And then after each, we simply remove, we just remove all the data from the database. So here we are using supertest in order to just make a random call to the server, and we expect to get a 404. And if we go to the root, we expect a 200. If we go to login and there's no session, or we're sending in something that is like we're not registered, right? So we're trying to log in with something that doesn't exist. Then we get the 401 back because we're not there's no user foo in our database. And then we check that we can register. So now we go to the register and we get redirected as expected. And then we do a find. And basically we do a little check to make sure that now there's actually a user in the database that has, after we register, we expect there to be a user in the database. Easy. And then we check that we can log in. So first we register, and then we try to log in, and we expect a 302 because we could probably make this test even nicer than this trivial example to just verify that we get to the right place and so forth, and check that we have a session cookie and stuff of that nature. But for demo purposes, I think this is good enough. And and then finally just a test that made sure that we have a 200 when we go to register. All right. The same thing goes for the to-do controllers, and we can kind of just gloss over this. So, all right, we do the sanity checks that if we go to a route that we don't have, 404. If we go to the to-dos, we expect to be redirected, and this is basically it. And if we send a post to the to-dos and there's no session, we get redirected as again. Remember, guys, these are just trivial tests that I kind of show you to kind of give you the idea of how this works. You can make much nicer tests than this, and you should make nicer tests than this. And finally, let's look at the service test. Now, this is the one where it gets a little bit messy if you don't do this in a proper way. Now, you saw earlier that I like to instantiate my services instead of because honestly, what I could do if I wanted to, and this is the thing I think that you shouldn't be doing, and it's basically this. I could require, instead of passing in my user model like this, I could just do an import at the top of this file. I could just require user. The problem with that is that if you do it that way, that means that you now have your code is not you don't control the creation of your service. In other words, internally, your user service is going to actually use the database connection as you have to have the database connection, and you don't want that because a service it shouldn't be the thing that you're not interested in testing the connection to the database. You're just interested in testing that the logic that the service method is responsible for executing is actually happening, and you want to do that in memory without having to go to the database. So by passing in the model or your database connection, or passing in your quote-unquote impure methods or functions or database access interfaces as a dependency instead of having it as an internal thing, you can now control things. So if we look at my to-do service here, so listing all the to-dos. So what I can do now is I can create this fake to-do model which holds the find method and just create a stub function for that. I create my service, I call the services.list to-dos, and then I expect that my find method on the model was called with an empty object, because that's all the logic I'm interested in. If this was more complicated, I would test more things on this method, But that's right now the only thing I want. I don't want to have to actually spin up the database and actually make a call to the database in order to just test that this function is being called. Now, the reason for this is part one, it's very slow. It's going to get, if you do this for every single method you have or for every service that you create in a big system, your unit tests and your integration tests, like all your testing is going to take forever. I mean, it's already at 5 seconds and I'm just doing a few basic tests here. And you can imagine how quickly that's going to grow out of, to be really, really slow, right? And then we have this, like adding a to-do. So I create this empty to-do model. I just pass it in. And because, like, as we know, internally I have no, like, this add to-dos method. It doesn't actually use the instantiated model, or rather the model that I pass in. It just uses the model that I pass in, like the instantiation of one of the to-dos. And so I fake the save function, and yeah, then basically all I do is I check that the save function was called, and I expect that the return value from my to-do is to be a empty, that's just an empty promise, or a promise with an empty object. Because if we look at the function here, that's all it's going to do internally. That's it. So, to-do service right there. So if we had more complicated methods, this would still be the same structure. And I can only say that for me, it works very well when we pass in the model like this, because I don't like, there are tools that will let you do all this internally, but this is frankly the easiest way that I've found, at least in Node land. And then we have our user service, and basically we do the same sort of thing, right? We create a fake model that has the methods or the database accesses that we want to do, because remember, we don't care about testing Mongoose. Because some people will tell you that, oh, but if you do this, then you're not sure if the model is doing the prep, is going to access the database correctly. No, you're right, but quite frankly, if you want to test, like, you kind of have to trust that the people who created Mongoose know what they're doing, in my opinion. Because if you have to test all of their methods and actually make database calls and all of that stuff in as well as this, then you're kind of like, then you're testing their framework, their API on top of testing your own thing. And if you want to do that, more power to you. I don't like to do that because, as I said, I'm willing to risk that the maintainers of a project such as Mongoose, like have their own testing, and they kind of do the right thing, if you will. That's just my personal preference. I mean, if you want to test their APIs as well, you're welcome to. And then we instantiate our user service, and we get a user with the username and the password, and then we just make sure that find1 was called with the correct information. That's it. Remember, this is simple logic, but it can scale to almost any size of project where you have much more complicated stuff. The problem there is, and that's kind of where I think that functional programming comes into it, is that when you have a method, like a service that does a lot of stuff, there is a lot of boilerplate code and there is a lot of testing. The one real downside that I feel with this domain-driven development style is that testing is it's horrible. Especially in languages such as Java and C#. At least per my definition, there's a lot of mocking and stubbing, and the amount of stuff that you have to write a test for one of these methods is massive. And that's where I really think that functional programming shines, because it's much easier for testing purposes, but it has its own drawbacks. Everything is, there's nothing is perfect, guys. Nothing is a silver bullet. And then we have this simple test here, get a user by the ID, and then finally, yeah, here's the one that we just used to add a to-do. So hopefully, we kind of traversed and glossed over most of this, and this is the basic structure of how most of the larger sized enterprise level applications that I've been working on so far have structured their code base. And that doesn't mean that there's no other way to do this, it's just the way that I know to be one of the most common ways of structuring a project. So having a domain-driven design with a service architecture like this, as stated before, it's going to work at a small startup and it's going to work at a really, really large company. And hopefully you learned something. Have a great day.